Find a formula in n, a, m, and d for the sum a plus md plus a plus m plus 1 times d plus all the way up to a plus m plus n times d, where m and n are integers, n is greater than or equal to 0, and a and d are real numbers. Justify your answer. So let's talk about each term in this series. The first term, a sub 1, is a plus md. The second term is a plus m plus 1d. But if we distribute that d using the distributive property, this is a plus md plus d. And so to get from the first term of our series to the second term of our series, we just have to add d. For a sub 3, this is a plus m plus 2 times d, which if we distribute out, this is a plus md plus 2 times d, which is the same as the previous term, but plus another d. And so if you notice, each consecutive term is found by adding d, meaning that this is an arithmetic series. Now, the common difference in this series is d. The first term in the series is a plus m times d, and we can use this information to find a closed form for this series. So now we can write out this series explicitly. We'll use k equals 0 for the first index, and we'll go all the way up to n. And k in this case is going to represent how many d's we add to get that term. So the general rule for each of these terms would be a plus m plus k times d. And so this is why the index variable varies from 0 to n. When k equals 0, then this is just a plus md, which is the first term. If k equals n, then this would be the last term. So this is why I like this format for the rule of the series. Now we just have to rely on some rules to evaluate what this summation is. We can start by distributing out d. The next thing I'm going to do is I'm going to separate the numbers that don't have the index variable in the formula and the numbers that do, which is the k times d. And keep in mind that the rule of this series is still the entirety of this formula here. Next, I'm going to write this as two series. The first series is going to be a plus md, and the second series is going to be k times d. Now for the first series, you might notice that the index variable is not in the rule of the series, which means that we'll be adding the same number each time in the series. This is going to be a plus md plus a plus md plus a plus md, and so on, all the way until our index variable gets to n. So we just have to count how many times a plus md is added. Well, this is dependent on the number of terms in the series. Since k is our index variable, k varies from 0 to n, meaning that there are n plus 1 terms here. We'll come back to this series. Let's go to this series next. What I'm going to do for this one is I'm going to factor out this number d, since this number is not part of my index variable. So I can write this as d times the summation from k equals 0 to n of k. And now we're almost done. Since this is n plus 1 terms, each being the same term, this is equal to n plus 1 copies of a plus md. For the other series, we can use the formula. Now normally for this formula, the index variable has to start when k equals 1. But since k equals 0 is the start of our index variable, we have to be a little bit careful here. Luckily for us, if we plug in k equals 0, this is just 0, meaning that starting at k equals 0 here is actually the same as starting at k equals 1, which means we can still use our formula. The formula would be n times n plus 1 all over 2. And that is our final answer. Thanks everyone, and I'll see you in the next video.